Recently I've been making some compressed air engines, and as well as the duration they run, I've also been trying to determine their RPM. The way I've been doing this is recording the engine running in slow motion and trying to count how many rotations happen per second. Now the reading this gives is fine, but it's pretty time consuming and doesn't give me real-time data. To get real-time data of the RPM of the engine, I need a tachometer. A tachometer is used to measure the rotational speed of a shaft or a disc. Now these are pretty cheap to buy, but that would make for a pretty boring video. So I'm going to build my own tachometer using an Arduino.
Start it up!
There are two ways that I can think of to get this tachometer to work. The first one I can think of is basically what I've been doing already, and that is counting the number of rotations in 1 second and multiplying this value by 60 to get the number of rotations in 1 minute. The second one is to measure the amount of time it takes for one rotation to happen, and then divide 60 by that time. So for example, if it took 0.05 seconds for one rotation to happen, you would then divide 60 by 0.05, which would give you an RPM of 1200. For simplicity's sake, and since I don't need this to be super accurate, I'm going to go with the first method, since I think this is going to be easier to code, and I suck at coding. So now I've chosen the method I'm going to use to calculate the RPM. Now we need to decide what sensor I'm going to use to count the number of rotations. Now there's a couple of sensors you could use for this. You coupler use an infrared optocoupler, you could use an obstacle avoidance sensor, but I'm going to go for a Hall effect sensor. Mainly because I already had one in this heap of sensors. A Hall effect sensor can detect the presence of a magnetic field using the Hall effect.
No shit, Sherlock.
Basically, when there's no external magnetic field present, the signal will read high. But when there is an external magnetic field, then the signal will read low. So by counting the number of times that the sensor output changes in a set time period, you can calculate the RPM. Right. So now I know how I'm going to calculate the RPM and what I'm going to use to do it. Now's the fun part. The coding.
For fuck's sake.
So now I'm going to go through the code that this tachometer uses. I'll be super quick, I promise. At the start of the main loop, we set the number of revolutions and RPM back to 0. Then we see this attach interrupt line of code. An interrupt is basically a separate piece of code from the main loop that is triggered when a certain event happens. In this case, the event being the magnet triggering the Hall sensor. The interrupt function is very simple and basically just counts the number of rotations in a set time period. In this case, 1 second. After that 1 second delay, the interrupt is detached so that it can't interrupt the processing of the RPM data. If I was using just one magnet on the rotating disc, the output of the sensor would change once for every revolution. But because I'm using 3 magnets to hopefully increase the accuracy, for every 1 revolution there will be 3 changes in state. So I've accounted for this by using this pulses per rev integer. So the RPM is calculated by taking the number of revolutions, multiplying it by 60,000 milliseconds, dividing it by the number of pulses per revolution, and dividing it by the elapsed time. Then the calculated RPM is displayed onto an LCD screen. So I've just put the circuit together on a breadboard to see if it actually works. So I was given a reading, which is a good start, but to see if this is actually accurate, I'm going to record the motor in slow motion, manually count the number of rotations, and see how this compares with the value that the tachometer is given. I put the footage into After Effects and counted the number of rotations in 1 second, I counted 39 rotations in the 1 second time period, and multiplying this by 60 gives a value of 2,340, which was exactly the same as the RPM reading from the tachometer.
Great success!
So does this mean the tachometer is 100% accurate? No. To really determine how accurate the tachometer is, I should test it at multiple speeds and repeat these tests multiple times. But that sounds like a lot of effort, so I'm not going to do it. The fact that the RPM shown is stable when the motor speed is kept the same, and the fact that the RPM value changes as I change the motor speed, leads me to think that this is probably good enough for what I'm using it for. So now I know it works, let's get soldering. I'm gonna be real with you. I fucking suck at soldering.
No, 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 no.
I really need to practice my soldering. Now I've confirmed it works, even with my shitty soldering, I'm gonna design a case for it.
Ain't nobody got time for that!
Parts took about 20 hours to print. So it's a good job it fit first time, because I definitely wouldn't have been printing it again. So all that was left to do was test it with a case on. Now surely, because it worked without the case, it should work with the case. Right? Right?
Wrong.
For some reason, the readings were either coming back wrong or at 0. So I took the top part of the case off and tested it, and it seemed to work fine. So then I put the top part of the case back on and tried it again, but it still didn't work. What the fuck? The only thing I could think of was that there was something wrong with the signal from the hall sensor, so I double checked the wiring, resoldered the joint, and put it all back together to try again. Please work, please work, please work, please work, please work, please work, please work. Yes! So despite this probably being the most oversized tachometer in existence, it does the job I needed to. Anyway, now I've got my tachometer, the only changes I need to make to my engines is to design a slot for the magnets in the flywheel, which is an easy change. So the next video is most likely to be another engine video, but if you like this kind of video, don't forget to give it a like and let me know in the comments. Thanks for watching, see you next time.
Don't ever do that again.